Alright, so today is Tuesday, November 4th, 2014. Welcome to week 2.4 of Togetherness. Ready to learn?
Ready to learn.
Okay, you need your Module 2 book, which is the new book. It is on the shelf behind the stool. You also need to bring home your Module 1 book. Do not throw it away because you will use it to review for EOC in the spring. Take it home. Don't leave it on the shelf. We need to make room for Module 2. Alright, once you get your Module 2 book, you are to get a marker, write your name on the spine and also on the front cover so you'll know that it is your book. Today's outcomes, today and tomorrow, because I'm going to try to cover Lesson 1 and Lesson 2 in the book, but it is, I can understand the difference between mean and median values. We're also going to be looking at how statistics are distributed on different diagrams, like the box plot, the line plot, the histogram. So we're going to be looking at the distribution of data. And then also we're going to be modeling with mathematics by using box plots and histograms. The outcomes are on the board for you. Today's question, tomorrow's question also is, what is the difference between mean and median? Mean and median. Homework tonight. That's going to be open for discussion. Because we also need to talk about scatter plots, but I may table that for December. We'll talk about it later. Alright, so let's get started with Lesson 1 in the module book, distributions and their shapes. Student outcomes. Students use informal language to describe the shape, center, and variability of a distribution based on a dot plot, histogram, and box plot. And recognize that the first step in interpreting data is making sense of the context. In other words, understand what the problem is trying to tell us. So here we go. On the screen, statistics is all about data, and this module is all about statistics. Read the bottom of the screen to yourselves. Alright, so we're going to be studying stories that begin with data. Dot plots. Do they look like something you've done before? Mm-hmm. What were they called before? You use X's instead of dots. Was it called a dot plot or was it called a line plot? Line plot. It's called a line plot. That's what I thought too. Alright, so a dot plot is a plot of each data value on a scale or number line. What kind of story is this graph telling? Can anyone tell me something they notice about this graph? Raise your hand, speak. First of all, look at the data, look at the title of the story, and then look at the information that is contained in the story. Can anyone tell me something that they notice? Alright, Jake, what do you notice? It is a type of graph. Can you go just a little bit deeper? It has deeper. Come on, just a little bit deeper. It's a type of graph and it has dots. That's like saying it's a story and it has a title. Table tab.
Each dot represents one person.
Each dot represents one person. Okay, where do most of the people lie?
70 and 71.
Alright, somewhere between 70 and 80. Agree? Yeah. Okay, so fourth period, third period has said that most of the data, or the majority of it, is right here in the 70, and that this story is telling a story because it has a title and dots. Thanks to Jake. Moving on. Histogram. What is the name of it? Ages for Kenya. Do you think Kenya is a country or do you think Kenya is a person?
A country.
Alright, so Kenya is probably a country. What can we conclude about these lines?
They get smaller.
Do they die early?
Maybe they move out.
Maybe they move out. Okay, so go back. What type of graph is this?
Dot.
Everybody on 3. What type of graph? 1, 2, 3.
Dot.
Type of graph? 1, 2, 3. Type of graph. 1, 2, 3.
Dot plot.
Type of graph.
Histogram.
Alright, moving on. This is a box plot. When I was in school, it was called something else.
Something whiskers.
What was it?
Box and whiskers.
Box and whiskers. Box and whisker plot. It is divided into quarters. 25% of the data lies between each part of the box plot. And this box plot is showing the number of pets. Look, what is that? So why is that astronaut there? What is it called? Do y'all remember the word? But what does the asterisk represent? Think. It starts with a O. It's not orangutan. It's not opposite.
An octopus.
No, it's not an octopus. Outlier. Outlier. That's an outlier. Alright, name the graph on 3. 1, 2, 3. 1, 2, 3.
Histogram.
1, 2, 3. I know, this is a very difficult lesson. So sorry. Okay, now, here's where the statistics start to come in. Find this page in your book. Do you have it in your book? Okay, you don't have it in your book. We need to draw this in your book. So turn to, that's a good page. Page 2. At the bottom of page 2, I want you to draw the 3 diagrams that represent a right skewed, a symmetrical, and a left skewed distribution of data. So copy these 3 pictures onto page 2 of your module book. S2 of your module book. Variability of data, that is the shape of the data. Symmetrical distribution, the majority of the data is in the center. Skewed distribution, the majority of the data is at the beginning or at the end, and is said to have a tail and a hump to the left or the right. So let me show you. If it's a center distribution, most of the data is in the center. Copy those 3 diagrams along with the words left skewed, symmetric, and left and right skewed. This one, most of the data is in the center of the graph. These are the tails. That's a tail, and then this is a tail. And when we get into describing data, I want you to describe it as being symmetrical, right skewed, or left skewed. Everybody understand that part? This is like, hopefully not very difficult. What phase it's in? Right. It's which way it's going. Alright, anyone needs some more time on this page? You have the 3 graphs and their titles. 3 diagrams, I mean. Okay, now, I'm going to give you 25 minutes to answer pages 3 through 7. Turn the page. And you are going to answer the questions that accompany each graph. You have 25 minutes. Yeah. Alright, get started. Okay, at this point you're going to pause the video, work on the exercises for 25 minutes, and then come back and press play. So press pause for 25 minutes and come back. You all, get started. Work. Okay, so we did not wait 25 minutes, but we decided we're going to have a discussion Those of you who are in the front, turn your desks around or turn your chairs around and face the circle. Can you what? Yeah, you can pass the microphone around instead of the block. It should be over on that cart somewhere. Hmm? Take the ball and throw it. What if they don't catch the ball? They might intentionally miss the ball. Alright, no, you have the mic. Go sit. Okay, so let's all turn to the first problem, which is the dot plot of December delay times. Alright, Carson, what do you think this graph is telling us about the flight delays for these 60 flights?
It is saying an average, or no, not average, what people wait on flight delays before they get the next flight.
What people wait, what? Wait.
How long they wait if the flight gets delayed.
Okay, so he says, it tells us how long they wait for the flight to be delayed. Survey says most flights are delayed for 15 minutes, some are delayed for a longer time. Pass the mic. Alright, Mr. Max, can you think of a reason why the data presented by this graph provides important information? So we can decide if the airport is reliable. Go ahead and pass that mic before I show the survey. Alright, Taylor Brown, who might be interested in this data distribution? The transportation officials. Alright, survey says if flights are late, travelers would not select this airline, and big air and travelers using this airline would be interested in this information. Very good. Pass. Alexis, based on your previous work with dot plots, would you describe this plot as representing a symmetric or a skewed data distribution? She says skewed. Dustin, do you agree? Dylan, do you agree? Why? He said because most of the data is piled up to the left. Survey says, woo, woo! Yay! Alright, next page. Alright, on the next page we have a dot plot of viewer ages. So, Mr. Josh, what do you think this graph is telling us about the ages of 80 viewers in this sample? Alright, he said most of the viewers are between 77 and 88. Did you say 88 or 80? 70 and 80. Survey says... Oh, that says the typical age of viewers. Yeah. Alright, Jake, can you think of a reason why the data presented by this graph provides important information? Yes, I would like for you to share it with us. Ooh, very good. That is a nice one, huh? Survey says, this data is important in understanding... Go, Jake. He cheated. Sit down. Okay, Allie. Based on your previous work with dot plots, would you describe this data as symmetric or skewed? Skewed a little bit. Which way? Low and then high the left one. If she was going to put that on paper, let's hope she would say something like, it has a tail to the left. Woo! Questions? And the train keeps on rolling. Turn the page. Thank you for that. Life just wouldn't be the same without you, Carson. All right. We are now talking to Danielle. Danielle, we have a histogram of ages for Kenya. Danielle, what do you think this graph is telling us about the population of Kenya? That is exactly what I was going to say. Survey says ages 10 and younger. Haley Ann, why might we want to study the data represented by this graph? What the government got to study for? Okay, try. Why might we want to study the data represented by this graph? Somebody want to share? Say that again. What did she say? She hadn't done this one yet. Oh, you hadn't done this one yet either? Okay. Raise your hand if you hadn't done this graph yet. Okay, raise your hand if you hadn't done the other graph yet. The last graph. Is it the last one, the last 2 pages? Okay, let me ask you this. Do you understand why we are interpreting the data?
I don't understand box plot.
You don't know how to construct a box plot.
I don't know how to read it.
You don't know how to read it. Turn to the box plot. Let's look at it. That's another histogram. What page is this?
6.
All right, so let's talk about page 6. Here's what I can tell you about a histogram. I mean, a box plot, box and whiskers. This is 25% of the data. This is 25. This is 25%. And this is 25%. And I can tell you that this is called an outlier. Okay. Now, I can also tell you that when I taught how to create a box and whisker plot. Alright, so let's say I had data that was like, let's create a data. Let's create a data. And we'll divide it in a box and whisker, and maybe that'll help you understand the information. So let's insert a page, and I want to know the day of your birthday. Alright, so I'm going to go around the room and just tell me the day of your birthday. And then I'm going to put it in numerical order. So, how many people have a birthday on the 1st? Raise your hand. 2nd. Third. 4th. 5th. 2. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. Ooh, that's 3. And 30. 31. Okay. Here's what I want you to do, all of you. On the back of the page that you're on, I want you to write these numbers down and divide them into 4 parts. Here's what I want you to do. Write down these numbers in numerical order. Find the median. Split it in half. Okay, there are 22 values. So the median will be between the 10th and the 11th maybe. Let's see. Take off 1, take off 1. Take off 2, take off 2. 3, and keep going till you get to the center. 4, 5, 6, 7, 8, 9, 10. Here is the median. 15 and 17. So the median will be the 16 that is not shown. Alright, the next thing I want you to do is construct a number line across the bottom. Get a straight edge. Construct a number line and evenly divide it so that you can see where the numbers will lie. So go get a ruler, get a straight edge, and draw a number line. Including you, fourth period. Get a number, go get a ruler. Draw a straight line. You're going to make a number line that reflects the values 1 through 31 because that's how many days there are in the year. So this will be 1. This will be stop. 31. I guess the middle day would be 16. Alright, in between this will be 8. I'm going to add about what, 9? So maybe 25, 22. Sounds good to me. Okay, so right now I'm just making a number line equally divided. Half of 8 would be 4. 8, 12, 16, 20, and maybe 25 or 26. 27. 27. No, we're getting ready to make a box and whisker, a box plot. But in order to do that, you need a number line first. So I'm making a number line. 1, 2, 3, 24, 25, 26. Okay. Once you have that, you have located the median. That's going to be your straight line in between your box and whisker plot. Then you're going to take the lower half of the data. That's this part. Everything is white. You're going to take the lower half of the data and define its median. Then you're going to take the upper half of the data and find its median. So do that. The 16 doesn't count. That was not a value. That was the median of the entire data set. 10 is in the middle? Alright, so you're going to put another box at 10. And then 24.5. So here will be the median of the upper half, which is approximately here. The lower number, 29, that's going to be the tail of your data. And then 1 will also be the other tail of the data. Now, if we had somebody whose birthday was like on the 31st, we might call it an outlier if it was more than that. But for this one, there is no outlier. So this will form your box and whisker plot. So now we just draw the boxes. So I think drawing the boxes will help you be able to interpret the information that's given. I'm wondering why this side, I was looking at the graph in the book, and I was wondering why an area of the box is bigger than another area. So why is this area bigger than this area? What would be some reasons as to why this is a big box?
Bigger range.
So there's a gap in the values. Somebody else said something else too. Did you say that's where most of the numbers are? Uh-huh. Is that true? Is this where most of the numbers are? This is between 16 and 24. Here to here. Why is there such a big gap?
Because they're bigger numbers.
You think it's bigger numbers? What happened between, let's say, 10 and 16?
6 different.
1, 2, 3, 4, 5, 6 values here. There are 6 values here. How many values are less than 10? How many? Alright, so 5 values here. How many are between 16 and 24? $16 and 24? 25. That middle part. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's 7 values. And then this one is 28 and up, so 4 values. Now, if I'm not mistaken, I think that would explain the gap. Take a look when you finish. Look back at S7 in your module book. Go back to S7. That's not S7, is it? Alright, here's S7. Want to go back to 6? Let's go back to this one. Alright, so Haley Ann, we were at you and we asked, what does the box plot tell us about the number of pets owned by 30 students at River City High School? Now that we have constructed a box and whisker plot right here, we have an idea of what the values represent and why they are dispersed. What does this plot tell us? And you all can help her out. How many pets did most people own if you look at this and compare it to the one we just did? Let's call on Nick. Nick, between what values do most people own pets? 2 and 5. So let's see if 2 and 5 is what's under this box. Maybe we know what we're talking about. Alright, 50% of the students own between 1 and 5 pets. Well, we could assume that. Where is 1 and 5? Is this 5?
That's 4.
So here's, and this is 1. Oh, look, do you all see that 50%? I think we can also assume that this is a big bunch. Why would this graph be important? I don't know. Maybe somebody wants to have a fair for people who own pets. This line is the median. The median? The median of all the number of pets that people own. So that's the middle value. Like if I went around and asked you how many pets do you all own, and we created a box and whisker plot, the middle value would be 2. Okay, last box and whisker, then we're going to call it a day. Here we go. 22 juniors from River City High School participated in a walkathon to raise money for the school band. The following box plot was constructed using the number of miles walked by each of the 22 juniors. First question, who are we on? Grace, say, what do you think the box plot tells us about the number of miles walked by the 22 juniors? Where would you say 50% of the students walk? Between what and what? Between what? 4 and? About 4 and 8.5 is 50%. 4 and 9-ish. Why is this such a big area? I'm going to table that question. Why is this a big area? Write that question down, please. Write that question down in your book, in that box, on page 7. Why is that such a big area? That's going to be the question that we're going to answer hopefully before this module is over. Turn to the very back of your module book. You will see exit ticket for lesson 1. It is after S150. I want you to tear out both pages for exit ticket lesson 1. Put your name on both pages and work on it now. When you finish, put it on the kidney table on your own independently. When you finish, put it on the kidney table. Get started. If you don't finish, it is homework. No, the first 2 pages, 1, 2, and 3. Problem numbers 1, 2, and 3. If you do not finish it, it is homework.